Hi, my name is Miranda McCumber. I plan to teach K through 2nd. I want to emphasize in reading and writing.
I'm Haley Valcourt, and I plan to teach first through third grade, and my emphasis would be mathematics.
Alright, so for our content presentation 2, we had MP2, which was reason abstractly and quantitatively. So for our first mathematics example, we had the lower level. Our problem is you have 3 buildings that are in front of you. Building A, Building C, and I said that wrong. Building A, Building B, and Building C. So you know that Building A is larger than Building B, and Building B is larger than Building C. So what can you conclude about Building A and how it corresponds to Building C? So we narrowed down our facts here. So you know Building A is larger than Building B, and Building B is larger than Building C. So what do you know about A to C? The solution is that Building A is bigger than Building C. Our second question is George is the same height as Mary. George is 5 feet 7 inches. How tall is Mary? We created a visual aid so then our students can look at that and use that as a strategy to figure out the problem as well, rather than just thinking about it inside of their head. So we have a picture of George and Mary, and we drew an arrow so they can visually see that they're the exact same height, which is 5 feet 7 inches. So then the solution is that Mary is 5 feet 7 inches as well, since they are the same height.
Alright, so our definition of MP2 is that making sense of quantities and their relationships, the ability to decontextualize, which would be like thinking abstractly to a given situation and adapting to it and trying to solve the problem, and then to contextualize, which is to pause and manipulate the process so you can solve the problem. To consider the units involved and the meaning of all their quantities, and then knowing how to use different properties and applying them to different problems. So like you could have a problem that you are learning about something with triangles and you have to use the Pythagorean theorem, but that may not be in this section exactly, but just have them knowing that they have to use that problem and how to use that formula in that problem without specifically saying they need to use it. Alright, so our example for mathematics, the higher level, we have a picture, and it's a straight line, and then there's 2 parallel lines next to it, and then we give them one angle, which is 100 degrees. And then in the problem we say that this line A is parallel to line B, so they know, and we want them to think abstractly and to realize that this angle is 100 degrees, so therefore the supplementary angle would be, or the opposite angle would be the same angle as that, and therefore they can get the angle from 100 all the way from line A all the way to line B, and they know that those are equal angles because they know that A and B are parallel, and they know that the opposite angles are the same. And then the adaptation for the lower level, we did it kind of like a circle. So we gave them the problem of how many degrees is needed to finish the circle, and then we gave them a hint of you already know half of it. And so we used the same numbers as the one above. We used 100 degrees, but we also put for the straight line the 80 degrees, since the straight line's 180 degrees. And so the students at the lower level can conclude that 180 is half of the circle. I need to double that, so I need to add 180 and 180 to get the full circle. And then you can do different problems like that to adapt from the higher to the lower levels. And then for different adaptations for other problems for K through 6, was giving the students hints on how to complete the problem without giving them the exact answer or the exact formula, just giving them different steps like, why don't you think about this, or why don't you think about how to do it this way, or try this step, instead of just outwardly saying like, you need to use the Pythagorean theorem, or you need to cube this number, that kind of stuff.
Like we gave in the last problem, we gave them a hint that said you already know half of the circle, which is 180, so you need to do 100 plus 80. So then they know, oh, I need to do the same exact thing to the other side, and then you could get the 360. So that was a small hint in the problem without actually giving them the full answer.
Another adaptation, we could just be using smaller numbers in it. We used easy numbers, 180. Those are easy to add together, but you can add smaller numbers like 16 and like 25, just so it's easier for them to add. Maybe they can do it in their head and work on their mental math. Same with 180. That's pretty easy to add in their head too as they get older in the lower levels. And the last one is putting a problem in a circle rather than in a line could help them visualize it better. And can't see it on here, but in our PowerPoint, you can see that we drew a circle on our lines of the 180, or the 100 and then the 80 degrees, so they can see that this line makes a 100-degree angle and this line makes an 80-degree angle, but they can see the full circle visualized rather than the high school one where we just put the lines and label them as angles.
So for our last model, it's the CIP model. So the students can connect information without it being directly said. The students can also adapt to using other mathematical ideas in more than one specific content area. So as Haley was saying earlier with the Pythagorean theorem, you don't have to just use that in Pythagorean theorem problems. You can apply that to the lower levels, and then you can also use it in the higher levels as well. You should also use deductive reasoning. So as we said earlier that the students were George and Mary were the same height, they should think about that in their heads. If someone was the same height, that they should be exactly the same unit. So this 5 feet 7 inches is George, so then 5 feet 7 inches would be Mary. Also, they should use prior experience and correlate it to their problems. So if they've had any personal experiences in their life, such as height, they could use like their mom and dad, and they could correlate that to the problem. And then teachers can guide students in a way without giving them the solution. So as we said earlier, giving them small hints throughout without actually solving the problem for them or giving them the direct steps.
And then there are resources, and that's all. Thanks.